Hi, in this video, we want to take a look at homals. So this is a Gifi method. All right, so what we've got going on is that I want to use principal component analysis, but I've got categorical data. Now, with this, I would like to some way, some shape, some form, do principal component analysis with my categorical data. So now, knee-jerk response, anybody who thinks about this type of data, categorical data, they're going to think, hey, convert it to dummy variables. All right, well, that seems appealing. That looks like it will work out, but there's a problem there. Whenever I do principal component analysis, roughly speaking, each column gets equal amount of influence over my PCA model. Okay, well now, if you think about what happens when I do dummy variables, if I've got 6 levels of categorical data, I'm going to have 5 or 6 binary vectors coming out from that when I do my dummy variables. Okay, well, that means that categorical data, which is considered like the lowest level of information, would have 5 or 6 times the influence that a numeric column would have. And so that just doesn't feel right. That doesn't look, that isn't like a great way to go. Another option would be to do binning and, use subject matter knowledge, bin everything into 2 groups and do a binary vector. That would definitely be reasonable. That, could do it. Excellent way. But let's try a little bit more slick way. Let's do something a little bit sexier. Let's do homals. All right, so what we're going to do, we're going to pass our data into an algorithm that's going to try to linearize our data, and it's going to try to consider the relationships between different variables when doing this. And then we will be able to use our homals, our version of PCA, and then proceed as we would with PCA as usual. All right, so this is a good tactic when I'm doing something like structure equation modeling. Okay, so let's go ahead and, something I need to say is that this is taken from Modern Psychometrics with R. I modified the code. It's by Mayor. Here's the GitHub site for you to get the code. This is a good book. You should dig into it. Now, if I had ordinal data, I would like to be using printcals. If I have categorical data, homals is a better way to go. All right, so let's load the data. So let's do the Wilson-Patterson conservative data. All right, so there's several items on the survey, and they're about conservative views or liberal views, depending on how you look at it. And it's going to be 0 for disapprove, 1 for approve, 2 for I don't know. All right, so if it was just 0 and 1, that's binary. I wouldn't have to be worrying about this. I wouldn't be in the situation. But since we have a I don't know, I don't have an order among these. And so what I'm going to do, I'm going to treat these as categorical data and proceed as follows. Now, when I load the data, there's some missing values in here. And so what I did, the missing values actually are not from any of the items. The missing values are from covariates about the population. And we'll look at those covariates in a moment. So just to make sure I don't lose too much data, I went ahead and just threw in the median for imputation, did median imputation, and I rounded it off to make sure that things jive with what's the rest of the data is doing. And so these covariates are liberal conservative, left right, and age, and there's also gender and country. All right, so I was playing around with this before I made the video, and I really wasn't satisfied with liberal conservative, left right, and age for the output that I was getting. So I modified the author's code to go ahead and bend these values into just 2 different values. So I cut at the median, and less than median, greater than median, and less than median, greater than median for left right. So liberal conservative and left right are Likert scales 1 to 10. And I went ahead, just said, hey, take them, and these are stored as numeric values in the data set. I said, just take the median, split it up like that. There's A lot of people are reporting like middle values on that, by the way. And then age for some of the later models that we'll look at, age wasn't really coherent. So I went ahead and reduced it down to just 3 different levels. So here, this is a length 3 in the cut. That means I've got 2 levels coming out. Length 3, I've got 2 levels coming out. Length 4, I have 3 levels coming out. All right, so let's do more multiple correspondence analysis using homals. All right, so let's go ahead and reduce down the data sets. So let's look at gay marriage, sexual freedom, gay adoption, gender quotas, affirmative action, legalized marijuana, and then country. Okay, and the country is, you know, a covariate. That's not going to be an item. The others are, say, 1, 2, 3, 4, 5, 6. The other 6 are items from the survey. Okay, so let's go ahead and just run homals just as a quick example. And so we can see our loss value is 0.663. It took 22 iterations to converge. Our eigenvalues are about 3 and 2, rounding off. Now let's go ahead and look at the joint plots so that I can get a better feel for what's going on. And you'll notice I'm using the Viridis color palette to plot these. This is my favorite color palette. All right, so when I look at this, remember that 0 was one response, 1 was the opposite response, 2 was I don't know. So look at the 2 responses first and foremost. So I say I've got 2, 2, 2, 2, 2, 2, all up here. Okay, so when I look at this, I see that dimension 2, all the 2s are vertically higher, and so along the vertical axis. So dimension 2 and the number 2 is a coincidence, is basically detecting, does the person have like an opinion strong enough to give a response? Now, when I look at the first dimension, we can see that we've got 0, 0, 0, 0. And then we've got India, Hungary. We have a 1, 0, 0, 1, 1, 1, 1. Okay, so what's going on is that we can see that there's kind of like a separation going on between the 1s and 0s, but affirmative action and gender quota are like flipped from the others. Huh, kind of interesting. We can see that India is more on the 0 side. The US is more on the 1 side for gay marriage, gay adoption, sexual freedom. And Hungary is prone to saying, I don't know. So recall, if we scroll back up, is that 0 is disapprove, 1 is approve. So the United States is approving of these liberal ideas and disapproving of these 2, while like India is going in the opposite direction, and Hungary is prone to saying, I don't know. All right, so now let's look at homals on mixed input data. So here, I'm going to take several questions from the survey. I'm going to grab some covariates and run my analysis. So this is the country that they live in. Do they self-identify as liberal, conservative, left or right, gender and age, demographic information. And here there's a few missing values from our country, from country. And so I just went ahead and threw those out. Now, on the next step, we're going to go through and we're going to define our splines for our homals. All right, and so remember, these are polynomial splines. Frequently, these are linear or quadratic in this particular example. And I'm going exactly with what the author did in the textbook off of this one. I'm not mixing it up. So here are all of my items in terms of conservative or liberal. And we're putting our knots at the data points. For country, we're putting our knots at the data point. for liberal conservative at the data point. Left right is at the quantiles, and we're doing a quadratic degree 2 cubic splines. The other ones so far have been degree 1. For gender, it's also at the data. And then age, we're putting at just the endpoints. So we just have one model going across. We're not breaking it up. So it's really not even a spline. And then to be able to use these, we put them all into a list, and R will figure out how to handle these from there. So let's go ahead and fit the mixed homal model. And so something I need to do, I need to declare which ones are ordinal, which ones are not. All right, so we know that for my item responses, they are not ordinal, so I put in false. And then we go false, true, true, false, true. Now age is technically numeric, but we're treating it as ordinal in this situation. Remember, I did bin it. And then here for degrees, we're putting in -1 or to like figure it out on its own. 1 says I want it to be linear. 2 says I want it to be quadratic. And then I actually fit my model using the Gifi package. All right, so let's go ahead and plot what we get. So we're just going to look at a few of them. Let's look at 6 of them. Okay, so what's going on is that these plots show us the transformations. So 0 in the, so when I see black and red, black is for first dimension, red is for second dimension. 0 is going with this negative value, small negative. Red is for this larger value here for in a different dimension. So along the first dimension, 0 is low, 1 is, you know, in the middle compared to the other vertical, and then 2 is the highest. Okay, now India and Hungary and US, we see that Hungary is the lowest, India is in the middle, US is the highest. Okay. Liberal conservative, we have low then high. Left or right leaning, low then high. Gender, low then high. And then age, it's a linear transformation on the 3 buckets. Okay. And then we can analyze the second dimensions on the reds as high, low, high, high, low, high, kind of like a U shape. So remember, when I'm doing this, I'm replacing my categorical data with numeric values so that I can pretend that it's numeric for other computations. Now, one thing that we can do, we can also go back to printcals and actually do this. You know, there's advantages and disadvantages in both ways. You know, if you start digging into the different ways to approach it, homals is more flexible. Printcals is less flexible, but you have more like model structure in there. So remember, whenever we use a very flexible algorithm, a very flexible model, things I'm going to be very prone to overfitting on my data. So I have to use flexible methods with caution. And so if you don't know, I would say use printcals before you use homals. So let's look at the loadings. All right, so here, when I look at the loadings, remember that we're going along the dimensions. So the first dimension really is separating gender quotas from all of the others. Remember, first dimension goes horizontal like this, and then second dimension goes vertical. So here, country and affirmative action is down here, and then the rest are going in the other direction in terms of component 2. So we can see that affirmative for component 2, affirmative action and gender quotas are like the most polarizing topics. Then would be country and sexual freedom. Legalizing marijuana is the least, you know, polarizing topic on the survey. We see gay marriage and gay adoption are really close to each other, which really is not that surprising. All right, so now here we want to go through and get another plot. We want to plot the joint plot. Okay, so what we want to do, we want to look at an individual line one at a time. And so let's start with country. I see US, Hungary, India. So remember previously when we looked, we saw that US was approving on stuff that India was disapproving, like they were going in opposite directions. And we saw that Hungary was, I don't know. And I noticed along this line, I have US, other end is India, Hungary is in the middle. Huh, okay. So now let's look at another one. All right, so it gets kind of tight and crowded. Let's look at sexual freedom. Then we have sexual freedom here. And so we can see like kind of like a line going through. In the middle, it's hard to see what's going on. So we have sexual freedom 0, sexual freedom I don't know, and then sexual freedom over here. And so, we can go through and start analyzing it in this manner, dig in a little bit deeper. Now, something that we can do to get more flexibility in our model is to use copies of our data to give us more flexibility in how we fit things. And so here, what we do, we take copies of our data and then we go through. And so as many dimensions that I'm going to use that number of copies or less. And this enables us to have more of a multi-dimensional approach to this. And this relaxes the linear restrictions on what's going on. And so I can do this with print cows. I should put this header above this code chunk. But here I'm doing it with print cows. And I've got 2 copies. And you notice that we're just going with 2 dimensions. And I can do the same thing, where I give the knots, give the ordinal vectors, give the degrees, and give the copies. So here, I want to copy everything twice. Here, I'm specifying how many times I copy everything. All right, so let's go ahead and plot some transformations. Let's look at what happened. All right, so legalizing marijuana. So here, down here is the horizontal axis is the original data values. The vertical axis is the transformed numeric values. So start at 0, and we can see it's a small negative value. 1 goes to close to 0. 2 goes to a little bit greater than 0.04. All right, so we can see that the 2 and the 0 are about equal in magnitude, but opposite signs. Now, country, or Hungary, goes to a little bit less than, so let's just say negative 0.05. US is going to positive 0.05. India is getting transformed to 0. Now, liberal conservative, we have negative 0.05, and then the more conservative values go to positive 0.03. Now left, right. Now here we have the 1 to 6 gets the greater value, positive, and then the greater than 6 values, remember this was a Likert scale originally, go to small negative values. And then gender, small negative value and a little bit bigger positive values for male. And so what's happening is that if I was to take the sum of these columns, they would approximately be equal to 0. The reason why we're getting such weird tight numbers is to make sure that we have like certain features in terms of vector length. Now, age has kind of a funny appearance here. What's going on is that for young people, it's getting transformed positive, late 20s, early 30s, negative, and then positive for the old folk, which includes me. So it would be more, this plot isn't that clear, but it should look like a U. All right, so now let's go ahead and plot the joint plot so we can see what happens. All right, so something I want to point out on this is that we notice that liberal conservatives and left right are almost on the same vector. All right, so that tells me that left right, liberal conservatives, that vector of data is practically the same, and which is not surprising. Now they're pointed in opposite directions just because of how the algorithm works out. But remember, if I switch the sign of things, it's okay. It doesn't really change anything. So since these are in a straight line, I conclude that left, right, and liberal conservative are measuring pretty much the same thing. There is a difference. There's just not much. And then let's see, let's look through. All right, so let's look where we see our twos. So I have a 2, 2, 2, 2. And then I have 3 different countries. All right, so here, this country point is going to be, more than likely that's Hungary. And then we have gay adoption, gay marriage, legalized marijuana, affirmative. Now here, this is approve, affirmative action, gender quotas, disapprove. I'll bet you money this is the United States. And then, sexual freedom, gay marriage, legalized marijuana, these point of views, that's probably India. And so how I look at this is that the horizontal axis is going through and splitting off of conservative views or left-right views. And then the vertical axis is splitting by I don't know. So we saw this earlier. It's just this is a presentation that incorporates more value. So this is off of a different data set. All right, well, that's all I've got for you. Take care and goodbye.